Chapter number 2, Sequence and Series. Let us study. In this chapter, we will study Arithmetic Progression AP and Geometric Progression GP, sum of n terms of a GP, sum of infinite terms of a GP, harmonic progression and arithmetico-geometric progression AGP, and arithmetic mean, geometric mean and harmonic mean.
Hello students, today we will begin with the second chapter of Maths 2 Standard 11th, that is Sequences and Series. So let us understand what do you mean by sequences. Sequences are any series of numbers written one after the other in a definite pattern. For example, natural numbers. For example, all the even numbers written from smallest to largest. Maybe also we can write multiples of 10. All these are sequences where the numbers are arranged in a definite pattern. Now, sequences consist of numbers. Each number in a sequence is said to be a term. So, we can say that sequences are made up of terms. We can denote these terms by, say, letter T. So, I can say T1, T2, T3, so on will be the terms of a sequence. Thus, I can say that T1 is the first term, T2 is the second term, T3 is the third term, and so on. So, sequences are made up of terms in definite pattern or arrangement. Now, sequences can be of two types. What are the two types of sequences? One is finite sequence and the second one is infinite sequence. As the name suggests, finite sequence is one where the sequence ends after some time. That means we know the last term of the sequence. These sequences are known as finite sequences. On the other hand, infinite sequences are those sequences which are not finite. So obviously we do not know where the sequence ends. We do not know the last term of the sequence. So sequences are again, as I said, of two types, finite sequence and infinite sequence. Now, what do you mean by progression? Sequences where the numbers are arranged in a definite arrangement or pattern, but which follow a specific rule. That is, the next terms are found out by following some specific, say, mathematical rule. Then such sequences are said to be progressions. That is, from T1 we can generate T2 by following some mathematical rule. From T2 we generate the third term T3 by following the same mathematical rule, and so on. So sequences which follow a definite rule are said to be progressions. And my dear friends, you have already studied one type of progression in your earlier standards, that is arithmetic progression. Now let us see what do you mean by arithmetic progression. We have already studied this in the previous standard. Arithmetic progression is that progression where the definite rule of getting the next term is by adding a fixed number. That is, I can say that the difference between two consecutive terms is always constant. That is, if I say Tn plus 1 is my one term and the term preceding it is Tn, then the difference of Tn plus 1 minus Tn will always be constant. Let us call it D. D stands for common difference. Now, AP therefore can be written as, if I take A, that is small a, as my first term, D as the common difference, then my AP can be written as A plus D, A plus 2D, and so on. From this, I have also derived the last term, or I can say the nth term. The nth term is hence written as Tn is equal to A plus n minus 1 into D. Now, we can determine the nth term obviously only if the AP, that is a progression which is also a sequence. So this AP should be a finite sequence. only in case of finite sequence we can determine the nth term or the last term. So this is what you have about arithmetic progression or AP, which you have already studied in your previous standards.
Geometric progression, GP. Let us see some examples of GP. 2, 4, 8, 16, 32, so on. 3, 9, 27, 81, 243, so on are examples of GP. Then what is meant by geometric progression or GP? Let us see the definition. A sequence Tn is said to be a geometric progression if Tn plus 1 upon Tn is constant for all n belonging to n. In above example, 9 divided by 3 is 3, 27 divided by 9 is 3, 81 divided by 27 is 3, which means that Tn plus 1 upon Tn is constant in the above sequence. That means above sequence is in geometric progression. The ratio Tn plus 1 upon Tn is called as common ratio and it is denoted by R. The first term of the GP is A. Therefore, in GP, T2 upon T1 is equal to T3 upon T2, which equals to T4 upon T3, which equals to so on, up to equal to Tn plus 1 upon Tn, that equals to R. And nth term Tn can be calculated by Tn is equal to A into R raised to n minus 1.
Let us now see how to find the general term or the nth term of a geometric progression or GP. So let us see the terms of GP and find out the general term. Let a GP be such that its terms are T1 is A, that is the first term, T2 is A into R, that is the first term into the common ratio, T3 is AR square, that is the second term into the common ratio, and so on. Then in such a sequence, in such an order, if we keep moving ahead, we can get our nth term as Tn is equal to A into R raised to n minus 1. Now students, if you actually observe carefully, the first term I denoted as A, I can say that it is A into R raised to 0, because R raised to 0 will be 1. So A into R raised to 0. So for the first term, R has the power 0. For the second term, we can see that R has the power 1. For the third term, I can see that R has the power 2. Again, if I repeat, for the first term, I said R has the power 0, or I can say that for the first term, R has the power 1 minus 1, that is 0. For the second term, R has power 2 minus 1. For the third term, R has the power 3 minus 1. Similarly, for the nth term, I can write that R will have the power n minus 1. Correct? That's why I got my nth term denoted by Tn as A, R raised to n minus 1, where obviously A stands for the first term and R stands for the common ratio. Let us now take one example to understand how to find the nth term of a geometric progression, that is GP. So let us consider a GP as 3 minus 6, 12 minus 24, ... so on. So this 3 minus 6, 12 minus 24 is our GP, and they have asked us to find the nth term. So how do we find the nth term? Let us first analyze our GP, that is a progression. We see that 3 is the first term, so A is denoted as 3. So first term A is equal to 3. The common ratio found out by Tn plus 1 divided by Tn, that is minus 6 divided by 3, will be equal to minus 2. Also, if I try to check any other preceding or consecutive terms, that is 12 divided by minus 6, again it comes to minus 2. Minus 24 divided by 12, again it comes to minus 2. So my common ratio R is equal to minus 2. Now to find the nth term, we know that the formula for Tn is A R raised to n minus 1. In our case, A is equal to 3. r is equal to minus 2. So I can say the general formula for nth term for this particular geometric progression will be equal to 3 minus 2 raised to n minus 1. Now, my dear students, if you have been asked to find a specific term, let's say they ask you to find the 10th term, simply substitute n as 10 in this formula. So if you had to find out the 10th term of this particular geometric progression, you would have written 3 minus 2 raised to 10 minus 1, that is 9. So if you find out the 9th power of minus 2 and multiply it to 3, you would get your 9th term. So this is how you find your nth term from the formula Tn is equal to ar raised to n minus 1. Let us now see some important properties that we can derive out of the basic definition of geometric progression. Let us see. So, if for a given geometric progression, T1, T2, T3 and so on are the terms, then I can say that 1 upon T1, 1 upon T2, 1 upon T3, that is the reciprocals of the terms of the GP are themselves also a GP. Correct? So, for example, if I have few numbers, they are in GP, let us say 2, 4, 8, 16 are in GP, then I can also say that 1 upon 2, 1 upon 4, 1 upon 8 and so on will also be in GP. Similarly, for few terms like T1, T2, T3 to be in GP, I can also say that if I multiply each term by a constant number, that is KT1, K into T2, K into T3 and so on, when K is not equal to 0, then such a series or sequence will also be a GP. The last property is, if T1, T2, T3 and so on is a geometric progression, then I can say that T1 raised to n, T2 raised to n, T3 raised to n and so on will also be a GP, that is geometric progression. So these are few important properties of geometric progressions which we can use in solving the questions or sums. Now, some important points to be noted so that solving the sums becomes easier, solving the sums of geometric progression. So the three important points that we need to note are as follows. If you have a question where you have to assume three numbers to be in GP, the assumption should be of the form a upon r, a into r. That means you should assume the three numbers in GP to be a by r, a and ar. Obviously, you can see that the common ratio here is r. Now, why do we do this? Because if they give that the product of those three numbers in GP is some value, and if we multiply these three numbers, we can see that r in denominator and r in the numerator of the last term will get cancelled. We'll be left with a cube. And hence, it will be easy to determine first the a cube, then we substitute in some second condition and find out our r. Similarly, if they want us to find out four numbers in GP, then the assumption should be a upon r cube into a upon r, ar cube. So, the four numbers in GP should be assumed in this way. Here, if you note, the common ratio is r square. That is, when we multiply r square to each term, we get the next consecutive term. Now, the same rule as I said in the first note, the same is applied here also. When we take the product, the r gets cancelled and we can easily find first a, that is the first term, and then we find the common ratio r. The third point to be noted is when you have to assume five numbers in GP. Five numbers in GP are assumed as a upon r square, a upon r, a into r and a into r square. Here the common ratio is r. So this is how, if you take the assumptions, the solution becomes much more easier than it seems to be. So it will be easy for us to segregate, that is first find the first term, that is a, and then find the common ratio, that is r, and then whatever else they have asked in the question.
Subscribe to my channel. Click on bell icon to get notification about new video.